Let's do IXL 8th grade T13. Go to Learning, go to 8th grade, and then go down to T13, surface area of cones. All right, hopefully you watched my video explaining where the formula for the surface area of a cone comes from, the derivation of that formula. But right now we can just go to the reference pages, and on page 12 we have surface area. So let's go down to page 12. And to calculate the surface area of a cone, so first of all, we split it into two parts. So we need the area of the base, which is a circle, so that's just pi r squared, plus the area of this part around here, which when we open it up looks sort of like a circle, except a piece is missing. So it almost looks like the Pac-Man character. And it takes a while to explain, and that's why you should watch the video. But the area of this piece, which is the length around here, that's called the lateral surface, that turns out to be pi RL, where R is the radius of the base of the cone, and L is the slant length. That's the length from the tip of the cone to the perimeter of the base. And actually, we can write this formula in a different way, which is actually going to be easier for doing a lot of these problems. So notice that both of these expressions have pi r in them. That has pi r and that has pi r. So we can go ahead and factor out a pi r from both of these. And then inside the parentheses, we would put r plus L. Why is that? Because pi r times r would give us pi r squared, and pi r times L would give us pi RL. So actually, this expression is equivalent to this expression. And this expression is, I think, going to be a little bit easier, so I'm going to go ahead and use this expression for doing most of these problems. I think for some problems at the end, this way of writing it might be a little bit easier. So let's go ahead and do some problems. What is the surface area of this cone? We're going to use 3.14 as an approximation to pi, and we're going to round our answer to the nearest hundredth. So this is pretty straightforward. IXL is giving us the radius of the base, which it's saying is 3 meters long, and it's also giving us the slant length, which it is saying is 8 meters long. That's all we need to calculate the surface area of the cone. We just need the radius and of the base and the slant length. So recall the formula is pi r times r plus L. So now we're just going to go ahead and plug in 3.14 for pi, 3 for the radius, another 3 for the radius, and an 8 for the slant length. And now we'll just simplify a little bit. So this is going to become 11. So we have 3.14 times 3 times 11. But 3 times 11 is just 33. So we have 3.14 times 33. And We could do it by hand, but you know what? You go ahead and just use your calculator for this. That's fine. Okay, 103.62 rounded to the nearest hundredth. Well, the 2 is in the hundredths place, so we don't have to do anything. Just type all that in. 103.62. That's it. That wasn't so hard, right? I bet you looked at this exercise and you said, oh my goodness, this one looks so tough. It's really not that tough. So let's do another one. Is this one? Okay, so there's just a little twist here. Let me go ahead and plug in what I can plug in. So again, I'm going to use 3.14 for pi, and I'm going to use over here, this is the slant length 7. Now, what are we going to do for the r's? Now, you might say, well, Mr. Frydman, just go ahead and plug in the 6 like you did last time. Just take this number and plug it in right here. But no, you have to be careful because look at this dotted line over here. It's going all the way across. But the radius should not be all the way across. The radius should just be halfway. So if all the way across is 6, then halfway would be 3. So we're going to plug in 3 for the radius, not 6. 6 would be the diameter. 3 is half of the diameter. The radius is half of the diameter, right? Okay, so now we just have, let's see here, 3 plus 7 is 10. I'll write the whole thing out. So we have 10 over here times 3 times 3.14. 3 times 10 is 30, so we have 30 times 3.14. And that's going to give us, let's see, 94.2, I believe. Right? 94. Okay, yeah. So let's see if I'm right. Or I just embarrassed myself. Let's see which one it is. I was right. Hurrah. Okay. Good. Let's see. This one is exactly the same as the last one. So again, you have to be careful. Right over here, this is the diameter, not the radius. The radius would be half of the diameter. So if the diameter is 12, then the radius would be 6. So you can go back in the video, go back to that first question that we did. For the first question, the dotted line was only halfway. So that told me that that was the radius. But for this question and the last one, the dotted line is all the way across. That means it's the diameter. So that means we have to divide by 2 to get the radius. So 12 divided by 2 is 6. Then we would go ahead and plug it into the formula pi r times r plus L. But you know what? We did that twice already. It's nothing new. So I'm going to go ahead and skip to the next level. And this one seems to be the same as the last one. It's just decimals. So there's really no difference between this problem and the last ones. Let's see, except perhaps rounding at the ends. So, you know what? Let's go through this problem. So again, we're going to write pi r times r plus L. Let's plug in, we have 3.14 for pi. We have, let's see, that's going to be, what, 9.7 for the radius. And the slant length is going to be 16.5. Mr. Frydman, where did you get the 9.7 from? Again, this dotted line is going all the way across. So we have to take the 19.4 over here, and we need to divide that by 2, and that's where we get the 9.7. Okay, so the radius from here to here would be 9.7, not 19.4. All right, so let's go ahead, and this in here is going to give us 26.2. Oops. That's just 9.7 plus 16.5. And we're going to multiply by all this stuff. So that I will use a calculator for. So we have 3.14 times 9.7 times 26.2 equals 797.9996, and we are supposed to round to the nearest hundredth. Okay, so let's do that. So this is the tenths place, this is the hundredths place. So this is the place that we're trying to round to, but we have to look at the next digit over. Okay, and again, if you don't remember how to round, then please look at the reference pages. Rounding, let me delete all this for a second. Rounding is on page 1. Okay, so step 1, locate the digit that you're rounding to. That's the rounding digit. Step 2, locate the digit one space to the right. That's the decision digit. Step 3, if the decision digit is 0, 1, 2, 3, or 4, keep the rounding digit the same. If the decision digit is 5, 6, 7, 8, or 9, bump the rounding digit up by 1. Step 4, eliminate everything after the rounding digit. So you can see some examples here. Here, the rounding digit was the number in the tens place, and the next digit was a 4. So that means that the rounding digit stays the same, and then everything else gets eliminated. So this becomes 870. Here, since we were rounding to the nearest hundredth, in this case, the 2 was in the hundredths place, so that was the rounding digit. The next digit, the digit that we used to make our decision, was an 8. An 8 tells us that we're going to bump this up by 1, so that becomes a 3, and then everything else gets eliminated. So that would be 7.93. For the problem that we have over here, since we're rounding to the nearest hundredth, remember the hundredths place is 2 decimal places after the decimal point. So 1, 2, this is the hundredths place. That's also on the reference pages, by the way. It's place value. You can see tenths, hundredths, thousandths. You might want to zoom in a little bit, but it's all there. Okay, so this is the digit that we're going to use to make our decision. Remember, if this is a 5, 6, 7, 8, or 9, then this gets bumped up by 1. So that 9, if we add 1, becomes a 10. So that's a little bit weird. How are we going to put 10 in this space? Well, we're not. We're going to put a 0 in this space and then bump this one up also. But that's also a 9. So this is also going to become a 0, and this gets bumped up. So that's going. So our final answer is going to be 780.00. Okay. What? What did I say? Oh, I'm not 798.00. So, whoops. Yeah, I went too fast. I wasn't paying attention. Okay, so yeah, that should become, everything that I said was correct, except I typed in the wrong number. This 7 becomes an 8, so that should be 780.00. I said it again, 798.00. So just forget that happened. And remember, if you do get the answer wrong, please go ahead and read through the explanation that IXL gives you. Okay, and then you can hit got it. What is the surface area of this cone? So this one looks to be the same as the last few problems. So I'm going to go ahead and jump to the next level. Okay, what is the surface area of this cone? Well, that's exactly the same. Yeah. So maybe I'll give myself a chance. I'll redeem myself with the rounding. So let's do another rounding one to show you that I do actually know how to do this. So we have pi r times r plus L. So again, the radius, this dotted line is going all the way across, but the radius should only be halfway. So if the full way is 17.6, then we have to do 17.6 divided by 2, which is 8.8. Okay, and the pi, we're going to use 3.14. So we have 8.8 plus the slant length, which is 14.5. Okay, so now we have to do 8.8 plus 14.5 is 23.3. And then all of this gets multiplied. All right, so let's put that in the calculator. We have 3.14 times 8.8 times 23.3. Okay, and then round to the nearest hundredth. This is the hundredths place, but this is our decision digit. So remember, if this is 5, 6, 7, 8, or 9, then this gets bumped up 1. So that 2 is going to become a 3, and then it's going to be 643.83. Okay, let's see if I redeemed myself here. Yay, got it right. Okay. See, I do know how to round. Okay, this one, this actually is the radius. So this one we would plug straight in. I'm not going to do the whole thing, but just to show you, because this is actually halfway, it's not the full way, then we would actually plug in the 12.7. We would not divide that by 2. For most of the other problems, we were dividing by, we were dividing by, we were dividing by 2. Because it gave us a dotted line all the way across. All right, so I'm not going to finish this one because it's the same as all the others. So I'm just going to jump to the next level here. The surfaces, so this problem is different. Now it's giving us the surface area, and it's asking for the slant length. Okay, it's saying the surface area of the cone is 571.48 square feet. What is the slant length, or it's calling it the slant height of the cone? So this time, we have to try to figure out what this is. Okay, this time, you know what? I'll call that L like it was before. We have to figure out what L is. So what we're going to do here is we're going to write out the whole formula for the surface area. I'll just put, in the video for surface area, I used SA, for surface area, but I'm just going to write A here for surface area. So the formula is the surface area, A, is equal to, now what I'm going to do, I actually could, sorry, page 12. Okay, so I actually could go ahead. Remember when we were back here earlier in the video and I said that this is equal to pi r times r plus L, and that's the formula that we've been using. I could use this formula. I could still use it, but actually I'm going to use this formula instead. I think it's going to be a little bit clearer for this problem. So let's go back to IXL. And let's say that the area is equal to pi r squared plus pi r L. And L is what we're trying to find. Now we know what pi is, or at least we know the approximation that we're using is 3.14 times r squared. Now we know the radius here is 7 plus pi times another 7 times L. Remember, we do not know what L is. That's what we're trying to find. But we do know what the area is because it told us that the surface area of the cone is 571.48 square feet. So now all we have to do is solve this equation for L. And I know it looks really complex, but it's actually not too tough. Make sure you have a calculator nearby. And we're just going to type in 3.14. I'm doing this term right now. Whoa, that was a little bit too long. I am doing this term right now. So we're going to type in 3.14 times 7 times 7 again, because this exponent means that the 7 is getting multiplied twice. 7 to the second power means 7 times 7. So I actually need two 7s in here. And then I get 153.86 over here. Okay, over here, oh, actually, I forgot to put pi over here. So there should be a 3.14 there. So now for this term, we're going to do 3.14 times 7, which is 21.98. Yep. So plus 21.98, but the L is still there, so don't forget to put the L in. And that is equal to, all of this is equal to 571.48. So I'm just copying from here to here. Nothing changed. All right, my next step is, now this is just the type of equation which we've solved a million times in class. So there's an invisible plus sign here. So the inverse of that would be subtraction. So we will subtract 153.86 from both sides. That cancels. And we get 417.6 over here equals 21.98 L. And now just go ahead and divide both sides by 21.98. Okay, this cancels. And I always seem to be running out of space by the time I get to the last step of an equation. So I'm going to write it over here. L is equal to, in my calculator, I already have this 517.6. So now I'll just divide that by 21.98. We get 18.999, so we get this big thing. But we are told to round to the nearest hundredth. So once again, the hundredths place is 2 places after the decimal point. So 1, 2, this is the rounding digit. The digit that we're going to look at to make our decision is the next digit over. That's this digit. So this digit is a 9, which means this digit is going to get bumped up by 1. But if we bump this up by 1, it becomes a 10. So actually what we're going to do is put a 0 in this place and bump this one up by 1 also. But this is a 9, plus 1 is again 10, so this will also become a 0, and this gets bumped up by 1. That's an 8. 8 plus 1 is 9, so our answer here is going to be 19.00. Okay, that is the slant length. There we go. Keep it up. Okay, so this is giving me another question, which is the same as the last one. So I'm going to jump a level. The surface area of this cone is this many square inches. What is the slant length of the cone? Okay, yeah, so this problem is the same as the last one. So I'm going to end the video there. Hope that was helpful. Reach out if you have any questions, and have a great day.